Hi and welcome everyone. In this lesson or in the previous lesson, we discussed one PV panel. We said that each panel produces a certain voltage and certain current. Now, how do we connect these panels? So we need to understand, are we going to connect them in series or we are going to connect them in parallel, and what is the effect of this on the output voltage and current? So first, before we discuss the panels, we will understand first the connection of batteries or the connection of different voltage sources. It is the same idea as panels. So here, as you can see, we have a 12 volt. This is a battery and another battery, and this another battery and battery. Now, what's the difference here? You will find that these two batteries are connected in parallel, and these two batteries are connected in series. Okay, you can see the red terminal is the positive, as you can see here, and the black terminal is the negative, or connected to the ground, and we have here positive, negative, positive, negative. Now, as you can see here, that the first one, these batteries are connected in parallel because negative connected with negative and positive connected with positive. So these batteries, each battery is at 12 volt and 500 CA, or something which is called cranking ampere, okay, which representing what? 500 cranking ampere representing 500 CA, for example. It means that this battery can provide 500 amperes for 30 seconds. Okay, usually we don't use in our PV system, we don't use the cranking ampere, we use the ampere hour, or how many amperes does our battery provide for 1 hour. Okay, so here, this configuration, we can say each battery can be considered as a voltage source, a DC voltage source. So we have the first battery like this, positive, negative, and second battery like this, okay, positive, negative. Now you can see that the negative terminal is connected with the negative terminal, so it will be like this. And the positive terminal is connected with the other positive terminal, so we will be like this. Then the final output, which will be this terminal, and this terminal will be connected to any load, for example a resistance. So what will happen here? You can see here we have a 12 volt, another 12 volt. This battery will provide a current I1, and this battery will provide current I2. So what is the voltage across resistors? Since they are all in parallel, so the output voltage will be 12 volt. And what is the total current going to the load? The total current is the summation of these two currents, I1 plus I2. So in this case, you can see that a 12 volt 500 cranking ampere and another 12 volt 500 cranking ampere. These two connected in parallel gives us a final output voltage of a 12 volt, similar voltage, but the summation of the two currents, 1000 cranking ampere. Okay, so when we connect the batteries in parallel, we increase the total current or the total ampere. Okay, now let's see the second configuration here, which is the series configuration. You can see we have a positive, negative, positive, negative. So we will have like this, a battery like this, positive, negative. Okay, now you can see that, let's see, for example, the first battery, you can see here positive, negative, positive, negative. You can see that the positive connected to the negative. So if we add another battery like this, negative and positive, you can see positive connected with negative. You can see positive connected with negative, and the final positive terminal and the final negative terminal are going to the load like this. Okay, So what will happen here? You can see that the current coming from first battery is equal to the current going out from second battery. So the total current is also the same current. So if this one I, this also will be I, and the current going to the load is I. However, you will find that the voltage across the load here is from here to here, which is a summation of the 12 volt and another 12 volt. So the total voltage across the load is 24 volt. So as you can see, the 12 volt series with another 12 volt battery, it will give us 24 volt, the summation of the two voltages, and the current will be the same. You can see same current flowing inside our circuit. So it will be 500, similar to the two batteries. So what do we learn from this? We learn that when we connect the batteries in parallel, we increase the total current. When we connect them in series, we increase the total voltage. Now, why did we discuss this? Because it is the same idea in PV panels. So as you can see here, the same idea for batteries. Again, we have plus minus, two batteries, 6 volt, 10 ampere hour, 6 volt, 10 ampere hour. Here you can see they are connected in series. So in series, they will have the same current, and the voltage will be the summation, which is 12 volt. Here for the parallel connection, the output current will be the summation, which is 10 ampere hour, and another 10 ampere hour give us 20 ampere hour, and the voltage will be the same. Okay, now the same idea for panels. As you can see here, we have two connections of panels. We have connected in series. When panels are connected in series, they form something which we call string of panels or string of modules. It means that we have group of panels connected in series. Why is this? To increase the total output voltage. And when we have strings which we connected in parallel, we form an array. This array will increase the total current. So as you can see here in this example, this panel, for example, produces 6 volt and 3 ampere at any condition, okay, in general. And this one produces 6 volt and 3 ampere. Or we can say, for example, these values are the values at peak power, as an example. So we have 6 volt, 3 ampere, 6 volt, 3 ampere, 6 volt, 3 ampere. Now you can see that each panel has positive and negative terminal. Positive, negative, positive, negative. Now when these panels, when negative connected with positive, negative with positive, it means that these panels are in series. So since they are in series, then the output current will be the same, 3 ampere, same current. But the voltage will be the summation, 6 plus 6 plus 6, which is 18 volt. Okay, so when we connect the panels in series, we form a string to increase the total voltage. Here the same idea, you can see 12 volt 5 ampere, 12 volt 5 ampere, and so on. When they are connected in series, you can see a positive with negative, positive with negative, positive, different terminals. When they are connected with each other, it means we have a series connection. So you can see the final output is same current, 5 ampere, but the voltage is a summation 12 plus 12 plus 12 plus 12, which is 48 volt. Now when we connect them in parallel, here we have, for example, if we have this string, 4 panels or 3 panels or any number of panels, you can see they are in series. Okay, so if this one 2 volt and this one is 2 volt, then the total voltage is 4 volt. So we have one string. Okay, now if we connect one string parallel to another string, okay, so if this panels produce 1 ampere, for example, okay, and this panels produce 1 ampere, then the parallel connection, which means we have an array, it will give us the summation of two currents. It will be 1 plus 1, which is 2 amperes. So as you can see, series connection or formation of a string, which is a series connection of panels, means we are increasing the total voltage. Parallel connection of strings, or parallel connection of two strings or more, it means that we have an array and we will increase the total current. Okay, so I hope the idea is clear. Why do we connect in series and parallel? In order to increase total voltage and total current. Now, as you can see, for example, this is a system for our PV. This is a PV system. Okay, so we have first the building unit, which is a fundamental building unit, which is a cell, which we have discussed before, which with its own different types, such as monocrystalline, the polycrystalline, and so on. We form using each cell, we form one module or one panel. Okay, then we take this module or this PV panel, connect them in series, as you can see in series. Let's say this positive, negative, then this positive, negative, positive, negative. So we will increase the total voltage. Now each string, like this one string here, connected in parallel with another string, connected in parallel with another one, we will have a large array. Okay, so the module is formed of cells, and the string formed of modules in series or panels in series, and the array is formed of strings in parallel. Now let's see what will happen if we connect PV panels or PV cells. It is the same idea in series and in parallel. You can see we have 0.5, 0.5, 0.5, 0.5 volt. When we connect them in series, they have the same current, but the difference is that the total voltage will increase, summation of the voltages. So as you can see here, for example, you can see this is a one cell, for example, one cell like this. This one cell have a maximum voltage of 0.6 volt and have a current, let's say maximum current 0.8 ampere. Now when we connect it with another cell with 0.6 volt and 0.8 ampere, we have two cells here. You'll find that we will have the same current, one cell, single cell, and two cells. Okay, you will find here the current is the same, but the voltage is increased. You can see, let's say here 0.6 volt and 0.6 volt. Summation gives us 1.2. Okay, so you can see that when we increase number of cells, the voltage will increase. Okay, you can see shifted to the right. Okay, here this figure is similar to this one. Okay, now when we have PV cells in parallel, what will happen is that the total current will increase. So if we have one cell like this, single cell, with a short circuit current of 0.8, then when we have two cells, the current will be doubled. 0.8 multiplied by 2 gives us 1.6, and the voltage here will be the same. You can see the voltage didn't shift, it is the same voltage, but the current is doubled. Now what if we have three cells? Then it will be like this, 2.4, which is 0.8 multiplied by 3. If we have more cells like this, it is the same voltage, but the current starts to increase as we increase the number of cells in parallel. So something which is important here, this figure, two cells in parallel, not series, parallel. Okay, the previous one here is the series, this one is parallel. Okay, now finally, if we combine all of this, what we will have, you can see that here we have one panel. Okay, as an example, one solar panel with a certain current and certain voltage, certain short circuit current, certain open circuit voltage. Okay, now if we add another panel in series, what will happen? The voltage will increase. So you can see the voltage shifted from here and became here. This is the new voltage. Okay, and what about the current? Current is the same. You can see this is the new old current, old curve, and this one is the new curve. Okay, the ampere is the same. Okay. Okay, now what if we have the same curve here and we added another panel in parallel? Okay, so we have a panel here and we added another one in parallel, so the total current will increase from here becoming here. Okay, and the voltage will remain as it is. Okay, now of course you can combine these two together. Okay, so for example, if you have panel like this in series, then you added you have two panels in series like this. Okay, you have formed this curve. Okay, if you connect with it two panels in parallel to it, then this curve will be like this. Okay, because you increase the total current. Okay, now of course in each case we have a maximum power point. Maximum power point, this point at which we will have maximum output power at a certain voltage and certain current. This curve has a maximum power point at which we will have maximum power. This is obtained by drawing the characteristics of the combined solar panels. Okay, so I hope the idea of series and parallel connection in PV panels is clear for you now.